In today's lesson, we're going to talk about comparing fractions and common denominators. Now, we compare fractions to decide which one is bigger. Now, let's start with a really simple example. For instance, 3/4 and 2/4. Which one is bigger? Well, let's look at a picture. If I have a pie and I want to eat 3/4, now remember the fourth says we're dividing it into 4 equal parts. So this is what 3/4 would look like, and I ate 3/4. Well, of another pie, you only ate 2/4. So who ate more? Well, it's obvious to see that 3/4 is greater than 2/4. So this little symbol is what we use to show that it's greater than. And math is its own language, but we read it from left to right. And so the symbol, when it looks like that, is greater than. If it's flipped, then it's read less than. Just as a reminder. Now, you probably could have done that one in your head, but what if you have 3/7 and 2/5? Let's look at what that looks like visually. We have 3/7 and we have 2/5. Now, it's easy to see that 3/7 is actually bigger, just by a little bit, but it's bigger. Now, what does that look like mathematically? And the reason why we want to know mathematically is because I don't know how many of us could actually draw this accurate enough to be able to truly tell which one is bigger. So there is a way to do this mathematically speaking. Now, it's harder to compare fractions when they don't have the same denominator. So 3/7 and 2/5, you can see the denominator 7 and 5 are not the same, and that is called unlike. So what do? Well, we're going to have to learn how to make the denominators the same so that we can then compare them. All right, so we need to change the unlike denominators into like denominators. One of the ways that we can do this is by finding the LCM. And the LCM, least common multiple, of the denominators is called the LCD. And that stands for the lowest common denominator. All right, so we have 3/7 and 2/5. We can multiply the two denominators together to find a common denominator. So 7 and 5, we want to find equivalent fractions for each of those that are over 35. So what does that give us? Well, if they're over 35, we say, okay, what do we have to multiply 7 by to get 35? And the answer is 5. Whatever we do to the bottom, we have to do to the top. So we're also going to have to multiply 3 by 7. So, 3 by 5. If we multiply 3 by 5, we get 15. Now let's do the same thing to 2/5. What did I have to multiply 5 by to get 35? Well, I know for my times tables, I have to multiply 5 times 7. Whatever I do to the bottom, I have to do the top, so I have to multiply the 2 times 7 as well. And when I do that, I get 14 over 35. So now I have two fractions that have the same denominator, so I can compare them. 15 is greater than 14, so we can say that 15 over 35 is greater than 14 over 35. Now, 15 over 35 is equal to 3/7, and 14 over 35 is equal to 2/5. So I can now use my original fractions and say 3/7 is greater than 2/5. Well, how about if I have 3 fractions? So here I have 1/3, 3/4, and 5/6. Now, don't just look at the numbers and think that means that it's bigger. We actually need to mathematically show that it's bigger because numbers can sometimes be a little bit deceiving. So let's find the LCM to compare. So we're going to find the LCM of 3, 4, and 6. So the prime factors of 3, those are just 3. Prime factors of 4 are 2 times 2, which we can write as 2 squared. And the prime factors of 6 are 2 times 3. Now, when we want to find the LCM, we need one of each base. So if we've got our bases 2 and 3, the last thing we have to do is to choose the biggest exponent of each base. So the 3 only has a 1, and the 2, the biggest exponent, is the squared. So this is 2 squared times 3, which equals 12, and that is our LCD. So now that 12 is going to be the new denominator for each of the fractions. So now we have to adjust the numerators. So what does that mean? Well, it means that if 3 becomes 12, then we must have multiplied it by something. So what did we multiply it by? Well, we multiplied it by 4. And remember, whatever we do to the bottom, we have to do to the top. So if we multiply the bottom by 4, we have to multiply the top by 4. So we multiply 1 times 4, and we get 4. So 1/3 becomes 4/12. Well, how about 3/4? We changed the 4 into 12, so we must have multiplied 4 by something to get 12. So the question is, what did we multiply 4 by? Well, we multiplied it by 3. We know that from our times tables. And again, whatever we do to the bottom, we have to do to the top. So we have to multiply the top by 3. Multiply 3 times 3, and we get 9/12. So we started with 3/4, and then it became, or is the equivalent to, 9/12. And the last fraction we had was 5/6, and we want to change it into something over 12. So again, 6 became 12, so we must have multiplied it by something. What was that something? It was 2. Again, we know this from our times tables. So whatever we do to the bottom, we have to do to the top. So if we multiply the bottom by 2, we're going to have to multiply the top by 2. And 5 times 2 is 10. So we have 4/12, 9/12, and 10/12. So now that we have a common denominator, we can simply take the numerators and compare the numerators. And we know that 4 is less than 9, which is less than 10. So from that, we can say that 4/12 is less than 9/12, which is less than 10/12. If we want to go back to our original fractions to compare them, we can now say 1/3 is less than 3/4, which is less than 5/6. 1/3 is equivalent to 4/12, 3/4 is equivalent to 9/12, and 5/6 is equivalent to 10/12. All right, so let's compare some fractions with unlike denominators. Now here we have 2 mixed numbers. First thing you want to do is change your mixed numbers into improper fractions. And remember how we do that. We take the whole number, multiply it by the denominator, and then add the numerator. So 6 times 5 is 30 times 4, and we get 34/5. Then 6 times 3 is 18 plus 2 gives us 20. So 34/5 and 20/3, we want to compare those fractions. So we're going to find the LCD of 5 and 3, which is 15. So what did we multiply 5 by, and what did we multiply 3 by? Well, we multiplied 5 by 3 and 3 by 5. So whatever we do to the bottom, we have to do to the top. So I multiply the top by 3 here, and multiply the top by 5 on the other side. So if we go ahead and do that multiplication, we get 102/15 and 100/15. So from that, we can say that 102/15 is greater than 100/15. Now we want to go back to our original fractions, and we can now say that 6 4/5 is greater than 6 2/3. Or we could have just noticed the 6. Now we know that 6 is equal to 6, so what we're really asking is 4/5 greater than 2/3, or is 2/3 greater than 4/5? And we would simply look at the 4/5 and the 2/3, and we could compare those fractions. Again, the LCD of 5 and 3 is still 15. So what did we have to multiply 5 by to get 15? And what did we have to multiply 3 by to get 15? Well, we multiplied this by 3, this by 5. All right, so if we go ahead and simplify by doing the multiplication, we get 12/15 and 10/15. And we know that 12 is bigger than 10. So we can say that 12/15 is greater than 10/15. Go back to your original fractions, and we can see that we have 6 4/5, which is greater than 6 2/3. And that is your lesson on comparing fractions and common denominators.